NBD, we are using cap and pin type of insulator for MV overhead line. So MV overhead line, as you know, is exposed to pollution, humidity, solar radiation and rainfall throughout the year. So this will degrade and also corrode the cap and pin type of glass insulator. So what will happen if this glass and pin type of insulator gets corroded? So when it's corroded, the leakage current along the surface of this pin insulator will increase. So when this leakage current increases, it will cause a surface discharge. Okay, so what are the complications for this cap and pin type of insulator in PNBD? From the statistics, as you can see, when this cap and pin type of glass insulator over time degraded, and then it will cause unplanned outages. So from the statistic, number of failures in financial year 11-12 is 29.
Okay.
And financial year 12-13 is 13. And financial year 13-14, there are 21 cases of glass and pin insulators failure.
Right.
So the major cause of cap and pin insulator failure is due to this cap and pin, due to the broken cap and pin. So as I mentioned earlier, this cap and pin, once it's corroded, it will give way. Dia akan putus. Okay. So a total of 63 broken pin insulator has caused this MV overhead line system interruption over these 3 consecutive years. So we have 63 cases in total, and until now, there is no investigation being conducted, and what is the root cause of this problem is still not known. So early inspections allows for detecting potential problem at the very early stages before they have progressed.
You are reading too much. Just explain.
Before they have progressed to a serious damage. So currently in MV overhead line, we are doing condition-based maintenance. So condition-based maintenance right now, there's visual inspection, infrared, and ultrasound. So these 3 condition-based maintenance will not tackle the problem of corroded pin insulator. So what actually do we need to solve this problem? Okay, what happens is when there's severe damage, there will be heat generated. So this heat, using infrared, you can detect.
Look at this.
But when there's already heat, meaning it's already too late. So anytime it can cause failure and unplanned outages. So we want something where we want to use an equipment which we can find or detect this problem at way much early stage. So we suggest, we would like to investigate using this ultraviolet imaging method, which is used to detect surface discharges at the cap and pin type insulator. However, a study to investigate the severity of this discharge. When we use the camera, which is readily available, the ultraviolet camera, when we capture, we go to site, we can capture the the discharges, the surface discharges. But how severe is this discharge? Is it tomorrow the pin insulator is going to
Fail?
We don't know. So yes, the current technology can give you that yes, your pin insulator is corroded, is having some problem, is having discharge, but it will not tell you how long you have to change this pin insulator. Therefore, we in the NBR would like to perform a study to study the intensity of the surface discharge emitted from the degraded cap and pin insulator. So by doing this, we can also know if the ultraviolet imaging is a successful method or is a suitable method for us to get an idea of how our cap and pin insulator is going to be. Okay. So at this point, using this method, it will allow the detecting problem at initial stage and before outages to the system. Okay. So the objective of this study is to establish a test method to artificially accelerate the aging of MV overhead line cap and pin insulator. So first, what we do is at site we have different severity level of degradation. Meaning at site, some insulators are there 3 years, some are there 5 years, some are there 10 years. But it all depends. Maybe the 10 years insulator is in a very clean environment. So being at a clean environment, it may not be subjected to high intensity of degradation. So when we perform UV imaging, most likely we may not get anything from a 10-year insulator. So what we first want to establish is a different level of degraded insulator with different humidity level, different UV level, different pollution level. So by doing that, we will study and later we will study the discharge emitted from this kind of degradation. So when we go to site, when we capture, okay, this pin insulator is emitting this amount of discharge, and then we see, okay, this is 3 to 5 years insulator, and now it's only emitting this amount of discharge. So we will be able to predict what is the lifetime or how severe is this cap and pin insulator. And lastly, we will also use modeling and simulation to see how what is the weakest point in this cap and pin insulator by modeling and simulation, because we cannot use a real cap and pin insulator to identify which is the weakest point. So maybe by modeling we will be able to identify the extreme stress area. So these are the 3 objectives which we would like to do in this research project. So first of all, what we do is we will obtain the glass insulators from site, and also we will purchase new glass insulators. This is for comparison. And we will carry out laboratory tests. We have the new ones, we have the aged ones, degraded ones at different level. And then we will, while the accelerated aging or the laboratory test going on, what we do is we capture these UV images. So when we capture the UV images, we will we will probably group it or tabulate the results.
Okay, good.
Yeah. So we will know, we can classify them into groups. So from this, and then we perform modeling and simulation, because by capturing the UV image, we will have an idea where actually the weakest point in our cap and pin type of insulator. And last, after the modeling and simulation, we will analyze the result and finally, of course, present the findings.
Good.
The laboratory test, what do we have in mind so far? We want to perform accelerated aging, which consists of UV, rainfall, and salt fog. Why these three tests? Because in Malaysia, our weather, solar radiation, the intensity is quite high compared to other countries. And our rainfall, we have heavy rain. And salt fog at different areas. Salt fog towards the sea, coastal area, it's going to be different. So we will also differentiate groups of insulators. And like I mentioned just now, we capture the UV, measure some leakage current, and then we are going to correlate this charge with the leakage current, and finally perform electrical tests and also mechanical tests. Mechanical test, we want to see the strength of the cap and pin type of insulator, and electrical test to see how much it can still withstand after going through all this accelerated aging. And finally, with all these results, we will be able to predict what is the remaining life of the cap and pin insulator.
Okay.
Okay, so end of the project, we would provide a technical report which consists of course, the test method and recording of the discharge emitted from the accelerated age cap and pin insulator. We will compare the discharge at different stages of aging, and we will also correlate between the new and the used or at site cap and pin insulator. And finally, we will be able to predict or predict the lifetime of the cap and pin insulator by just doing UV imaging at site, and hopefully we can tell you how severe this cap and pin insulator is. So why do this? Why we need to do this project? Benefits of it. First, of course, it will reduce the unplanned outages. As we have seen earlier, 63 failures in 3 years. So hence, by doing this, of course, we can improve the SCID. And also the second one, by predicting the life of cap and pin insulator, this insulator, using UV imaging method, we can detect this kind of problem, or detect problems at a very early stage instead of just waiting for it to fail. We can do something about it. Okay? And estimated value creation. Well, here is some assumptions for calculation. Operating cost for breakdown of MV overhead line is 17 million. Okay, and by using a detection tool like UV, we can reduce the breakdown. Assuming we can reduce the breakdown by 20%.
How? What is the basis of your 20% reduction?
The number of glass and pin insulator and the age.
I know, but why do you say 20%, not 10%, not 17%? Why 20%?
Maybe actually because we estimate like in a year we can visit, if I'm not mistaken, I can visit about 200 sites. something. So from the 200
Okay.
sites, if we able to detect about 60 something bit failures, so we will be able to solve that. I'm not sure.
Okay, never mind.
So if we take 20%, then our total savings for a year